Well, ladies and gentlemen, welcome and good morning to what is safely stepping into the clouds, or as I like to reword it, how everything just works. This is going to go through sort of the fundamentals of how cloud computing works, why it's important for you and the government, how to succeed, and also a little bit, hopefully, of how the cloud is evolving. If you've got any questions, please put your hand up. The lights are in my face, so you may need to wave around a bit. But as we go through, feel free to ask questions. But to keep a website online, things don't just work. To have a website, there are a lot of moving parts. There are many places and ways for things to go wrong. And systems stay up and running with thanks to the work of thousands of people. The whole internet is alive because thousands of people are doing their job tirelessly. I'm one such person, but I only do the Australian 9 to 5. So, about me. So my job is to administer and maintain cloud-based services for Acquia, which means that whenever there's a site or server down outage, got to jump in and fix it up, and also got to ensure that we can actually do our security compliance, such as FISMA and FedRAMP. Those are United States standards, but also do PCI and a couple of others, I believe. I don't actually use Drupal. That's up to other people in our organisation. I'm purely here from the systems and services side. Sorry, I got back from the snow on Monday and I think I've picked up something and I've got a bit of a throat. So yeah, I've been working for Acquia for just over 2 years now. Previously, I worked at TAFE SA in IT studies. It's a great opportunity to actually develop their educational network that the students use, and I got the opportunity to teach a couple of classes, which was kind of cool. I've been using Linux and free and open source software for over 10 years now, and the rates and the things have changed that it figuratively blows my mind. But today, we're talking about cloud computing. So what is the cloud, or what is cloud computing? Just out of curiosity, has anyone here actually been in a server room before? Oh wow, that's a lot of people. Cool. Don't be ashamed if you haven't. I was about to say that generally the access to them is highly restricted, but it turns out everyone here has got access to them. Great. Cool. So what makes the cloud a cloud? Well, you have multiple data centers in multiple regions around the globe, and cloud resources are, for the most part, ephemeral. The creation and deletion of resources like volumes and servers is trivially easy. So I suppose like normal clouds, there are lots of them. They're all around the planet, different sizes and shapes, and well, they're always up. Yep, that's like the normal clouds. So basically, the cloud is a bunch of servers run by a third party that you lease time and resources from. You take a normal server room and you scale it. So let's start at 30,000 feet and work our way down to ground level. So this is a map of the Amazon data centers around the world. They're located in multiple regions to provide resilience and also basic service. If you are a global company, this allows you to put your servers closer to your clients. So the longer the distance, the longer it takes. Light has a finite speed. Before Amazon opened up a data center in Sydney, for me to get to Singapore, if I can get the laser, I'd have to go from Adelaide to Sydney, to US West, US East, US West, Singapore, and that's on the way there. On the way back, it has to do the exact same journey to get back to me. The latency was hilariously bad. So thank you, Amazon, for opening up stuff in Sydney. But you don't just have one data center in each region. You need a bit more resilience than that. So you have multiple data centers. Each data center is essentially a massive warehouse filled with computers. Each data center is also geographically separated to insulate against power grid failures and natural disasters when they happen. My very first on-call for Acquia, 2 years ago. I woke up on Saturday morning and logged in, and because that was the Boston afternoon on Friday. So I logged in, took over the on-call status, checked a couple of emails. We're good. Literally within 9 minutes, we had a severity 0 outage where we'd lost a data center. These are not the servers you are looking for. They were no longer there, and we just had to deal with it. But because we always have our product in multiple data centers, we're actually able to get our customers back up and online, even though this one data center, for all intents and purposes, no longer existed. In this case, it wasn't actually a natural disaster. It turns out it was a number of different elements that turns out made the perfect storm. So, but with the help of my colleagues, many of whom we actually woke up, we got customers back online, restored service, and we even got our customers back online before some big businesses that also use Amazon, Netflix. So cloud computing is all about centralizing and optimizing resources. It's the economy of scale. If every government department was to run their own hardware, you've got to think about the power costs, location costs, like office space in the inner city is pretty expensive. Cooling, hardware, maintenance, administration, development, like the personnel involved is huge. By comparison, Acquia, we just got the tally in this week, that we actually now run over 8,500 servers around the globe. And all of those servers are administered by 14 people, 1-4. Comparatively, this time last year, I spoke at DrupalGov last year, we only had 5,000 servers. So if we were to try and scale by 3,500 servers in just 1 year, trying to buy the hardware, get it installed, configured, ridiculous. The cloud just makes it so much easier. So inside of a data center, you generally have servers which are designed for computing, and you also have servers which are there for storage. So the storage servers, of course, have terabytes of disk space that can be partitioned out. Now, assume you're on a project. You've got to worry about the number of visitors you're going to be getting, the pages per minute that you're going to be serving, any yearly events where you're going to actually have traffic spikes. I also got to worry about the availability, being able to have hardware in 2 separate locations for that resilience point. And whether your traffic is going to be anonymous versus authenticated, because if it's authenticated, then there's going to be a lot more load going through to your back end. So yeah, so instead of basically, in that situation, you'd have to buy enough hardware to suit your peak load, which means for the most part, the rest of the year, the servers are going to be idling, which is a waste of money. It's also slow to turn servers on. Waiting for a server to post and spin up all the disks takes ages. With the cloud, you can just start a server and it's pretty much there. As an example, one of our customers, Flight Centre, whenever they have special events on, we can proactively add in more web servers or increase the size of their database servers without any downtime so that they can, for a period, handle a lot. And so in a period, handle a lot more traffic. And afterwards, reduce the servers back down so it doesn't cost them as much. So the level of flexibility is there because the capacity is already there. Each server or chassis has up to 128 CPU cores and over 1 terabyte of RAM. So it can actually support a lot of machines on the one physical host. So if you've got a database server, and I've lost my notes, awesome. I'll wing it. So a database, generally you need a lot of CPU, a lot of RAM's good, and you need fast disks. If you've got a file server, you generally don't need that much CPU at all, but you need a machine that's got a fair amount of RAM in it, as well as a lot of storage. And running a website, say you're running Drupal, you need something that's actually got a little bit of RAM and mainly a lot of CPU power, because the processing of PHP is basically all CPU burn. So why is this important? Well, resizing for events becomes a lot easier. You can add hardware during peak usage and as spikes happen. Storage scaling. With Acquia Cloud Professional, a lot of our customers start with just a small 10 gigabyte volume, and as they develop and as they grow, they can increase that to 25 gig, and then maybe go up to 100, 200, 500, up to a terabyte. You just basically have as much storage as you need, and you only pay for what you use. The cost savings. Ultimately, you save money because you pay for what you're using. You don't have all this excess hardware sitting around. You also don't have hot spares and spare hard drives, RAMs, and CPUs sitting on the shelf. It's a waste of money. You don't have to worry about obsolescence. So hardware end of life, server life will typically be between 3 to 5 years. Don't worry about it. Specialization. You can build a server to do exactly what you want to do. The economy. You can run your own data centers and you can make your own cloud. But to provide a service like most public cloud providers, it's a massive technical challenge. It requires, well, like I mentioned before, the location, power, the hardware, the cooling, the person hours. It's just huge. But with any new technology, or it's not really new technology now, but with anything that's sort of, new and up and coming, there are pros and cons to it. So some things in IT are both good and bad. So I'll try and talk about the benefits, but also make you aware of points that you should probably be considering. So as with any issue, it's basically an exercise in risk management. So the pro is that hardware is someone else's problem. You no longer have to worry about physical servers, power, cooling, network, office space. Someone else handles that. The con is that hardware is someone else's problem. You no longer have physical servers to look at. You can't see the diagnostic front panel. You can't hear the BIOS beeps. You can't change the network, the switch settings to do other things. You kind of have to, I suppose, let go. And that is the mitigation. There are several diagnostics tools you can use to actually profile your machine, find out how good it's doing. But you just have to accept it, that you're no longer having physical servers. To be honest, I'm glad that I don't have to physically administer 8,500 servers. That would be nuts. It's easy to start and stop virtual machines. That's a pro. No more waiting for servers to post. Cloning servers is trivially easy. And also, your server in the cloud is independent from any hardware constraints. So if there's a specific network card or there's a specific, whether it's AMD versus Intel, you don't have to worry about that. You just have a server that just runs. It just works. The con is that your machine, a virtual server, still runs on a physical machine, and hardware does fail. But since you've got massive machines that are actually having or holding multiple servers, if one of those goes down, it actually does affect a lot more people. But the mitigation is you just simply use multiple servers, put them around the place, put them in different locations, and you get a bit of resilience. So when one goes down, you've got the other there to pick up the slack. So basically, have a minimum of 2 of everything. It's easy to create storage. It's really easy. This is the part where actually this. Haha. Good. Is that 100 or 1,000? 100. All right. If this works, come on, demo gods, work for me. But anyway, so what I'm trying to do here is create basically a terabyte volume. Just in one command, and come on. I'm trying to tab through my phone, it's a bit slow. This is burning my time up, I don't care. It's pretty cool. Oh, come on. Huzzah! I now have a new terabyte volume. Thank you. I'll deal with that later, just so my boss doesn't kill me for using up resources. Anyway, so how do we do that? Awesome. So the con, what happens when the storage subsystem goes away? Please notice that I did not say if, it's when it happens. The most devastating outages that you could ever have will happen one day. You need to be prepared for them. Like I mentioned before, I witnessed where that one data center went away. We lost all the storage there. We literally had to throw it away and copy it from the known good data center. Lots of fun. Well, once again, the mitigation, multiple data centers. So the pro is it's so easy to do that. You saw that in that command I had before. the AP Southeast 2 region, I use data center A. I could also use data center B. It is that easy. I just have to change one character and it's a completely different location. But con to that, of course, is that what happens when there's a regional outage. It has happened before, and I dare say will happen again. Murphy's Law. But in that case, generally the right answer is to turn off your computer and go to the pub, because there's not really too much you can do, other than actually have hardware in different regions. We do have a couple of customers like that, but I suppose from a government point of view, you have to be careful if you're going to be trying to store data outside of Australian shores. Only unclassified data, I believe, is allowed to go into public cloud. Anything that has a classification, you may need to keep a bit more private. So, which sort of ties into security and integrity. Data classification. So if data is unclassified, it can go into the cloud. If there's any sort of thing like protected, confidential, secret, you've got to keep that under wraps. All this stuff is available for you in the Protective Security Policy Framework. I'm pretty sure that's what it stands for, and the Information Security Manual. The ISM is a great resource. A bit of a read, but, you know. So yeah, we have to worry about data transmission between regions because it's going over the public internet. So we need to So between regions, you can use SSL tunnels. It's quite easy to use SSH and to actually connect securely from one server to another across vast distances. It's how I do that from my home in Adelaide and connect to those servers in Singapore. It's point-to-point encrypted. It's, for the most part, pretty secure. It relies on the public key infrastructure and asymmetric key pairs. You can also do full disk encryption to ensure that if anyone wants to grab a snapshot from one of your volumes, you would be able to, well, they would not be able to get into it because they don't have the keys. There are lots of measures you can do to secure yourself. There is also, Amazon has released what they call virtual private cloud, where you can have your own, essentially, private network in a public cloud. Which means that all the servers in your private network could be completely separated and segregated from everything else, meaning completely uncontactable from the outside world. You can have your own networks and even go from data center to data center with different VPN tunnels. A lot of the customization that you can do is pretty impressive nowadays. And once again, it just works for the most part. So, a couple of closing thoughts. That's working at scale. When you do scale up, it does have a few challenges that do need to be thought about and overcome. With enough planning, you can do anything. Have a look at, well, maybe not the nicest example, the Manhattan Project. That was where project management started. They had a complex goal to achieve, and they worked towards it. You just have to go through and do the risk management process for every single glitch. Services and security is for everyone. It's a public cloud. To be able to go online and actually use these services is insanely easy. I suppose a bit of a product plug is go to acquia.com and you can try out our free tier. You don't even have to pay us a single dollar, and you can try out using cloud-based services. It's that easy. So I think I've actually finished amazingly early. I must have been talking really fast. Have you guys been able to understand what I've been saying, or have I just been going crazy here? So yeah, that was all we had to go through. I'm more than happy to stay around and answer any questions you have. Are there any questions? Please ask. Yes, sir.
When you mentioned the issue of storage fail,
Yep.
it's easy to just add more storage in another data center. Underneath that, though, is the replication of the data on that storage. I think is a real challenge. At least Promise is happening as well.
Yep.
I saw you use GlusterFS. How have you found GlusterFS? A bit of a specific question, but is that how you solve that? Like, if data center 1 goes down and you move to data center 2, when data center 1 comes back, are you replicating data back again there? Or?
Cool. So the question for the recording was about how we manage, I suppose, replication of data between services, and I suppose what happens when there is an outage and how do we recover from that. With any clustering, you need to have decent fencing mechanisms around. So what we have is, it's kind of rudimentary, but it works brilliantly when we have an outage, is we simply just use a firewall block on all of the client servers. So basically, you tell the clients that if they're trying to connect to the known bad server, to simply reject the connection there before they've even tried to, which means that when that server that was in the affected area does come back, your clients aren't going to talk to it, they're still going to reject, and it's going to sit there in a bit of a, it's a siloed state until you can go in, verify that there was no data corruption, and make sure that your two servers are in sync. So you can sort of control the process a bit better. Did that answer your question?
Yeah, it's better to have a timeout than having temporary issues.
Yeah, and built into Gluster, it also has its own client timeouts, and also does some pretty rigorous checking of the files between the two bricks. Next. Yes?
Who else other than, obviously, Acquia uses the Amazon setup?
Yep.
How many, what's the volume of other Acquia type hosting providers that are using the Amazon setup?
So the question is, who else uses the cloud? So what are the big Acquia type companies? Well, I'm not sure that really anyone does what we do as big as what we do. A lot of respects, we're kind of pioneering, pushing a bit of that, which is kind of cool. I love techie things like that. But Netflix, they are entirely Amazon-based. They have a bit of a different, very different working model from us, but they are one of the first and largest of the Amazon success stories. And they have been able to basically grow their business massively and scale because the capacity is there and they can just use it. And once again, they just pay for what they use. So there are a couple of others. Bulletproof. Yeah, well, it's great. So more and more people are using cloud-based services these days as part of their business because hardware becomes someone else's problem. It just makes it a bit more economic. Yes, sir?
Just to add to that, Amazon has about 10,000 customers in Australia. So
Oh, really? So Amazon apparently have about 10,000 customers in Australia.
yeah, so lots. The question is with virtualization and cloud,
Yep.
the virtualization tax, noise and neighbor type problems.
Mm-hmm.
You guys are looking at some of these new services such as Docker, container type technology.
So the question is, how do we deal with noisy neighbors? Are we looking at things like Docker? So if you didn't know, Docker is a way of, well, it's known as containers. So you have the one server, except you have, I suppose, a number of different users, and the individual, I suppose, containers are completely siloed. It's very technical. I can talk at length about it afterwards if you'd like. But to answer the question, which I've actually kind of forgotten, do we use Docker? Are we going to use Docker? If we were to buy one of the larger servers, then we know that we'd get the lion's share of the I/O, and we could manage and control that a bit better. I believe that has been talked about and thought about. I'm not sure we're actually going to be doing that, considering how we currently handle our the spinning up of virtual machines and the management of our storage. We do have a couple of great Docker evangelists inside the company as well, so it's definitely an option and probably a better question for our technical guys, which I can put you in touch with if you'd like and if you see me after. So, yeah. Any other questions? Yes.
Could you please provide more information about Acquia cloud services offering?
Certainly. So the question is,
Little information about the enterprise class costings or like?
So the question is, can detail basically how Acquia use the cloud a bit more. As far as pricing, you need to speak to someone else about that. In fact, is David Peterson here? No. He's downstairs? Cool. I can get you to speak with one of the people afterwards, but to answer your question, so we start off with Acquia Cloud Professional, which is a single server, which has basically does the has the database on it, that's where your files are, that's where your web tier is. But it's a single server. If that goes down, well, you have no server. So what we do is we make 2 servers, which we have as a dedicated pair, which are, for all intents and purposes, identical. They both run database, they both run Gluster for the file replication, and they both run basically the web component. So if any one goes down, you've still got a database files and your web component on the other. And we can break that up further, and we do into what we call multi-tier, where we have dedicated file system and database servers, 2 of them, as well as separate web components, which is great because generally with Drupal, because it's so CPU heavy to actually generate the pages, you can just, most of the time, get away with adding more web servers, which is what we did for Flight Center a few weeks back, if you remember, Chris. Basically, they just needed web capacity, so we just spun up more web servers. The database and the file system was fine, and we just basically added more webs. So if that becomes even like that's still not enough, then of course you break out the file system and database onto into separate servers. So I suppose the way that we built it from the ground up is to make all the individual components, try and make it as modular as possible, so if need be, you can say, take this one service, move it away, and or separate it out. So you can, for instance, use one of those instances that has a lot of CPU and a lot of RAM for the database, a different type of instance for your file system, one that has a lot of RAM, not as much CPU. And it's very configurable like that. So there's many different options. Did that answer?
Yes, I was interested more about the services provided and whether there is an ability to quickly migrate or complete package, for example, to enterprise.
That would probably be a better question for, I think, Adam Malone, who's sitting down the front there. But maybe afterwards, because you don't have a mic. Yeah. Please speak to Adam. He should be able to help you out afterwards. You're welcome. Are we good? Well, I think I've managed to finish up ridiculously early. It's only 12 o'clock. How long do I have until? Oh, sorry. Hey, how you doing?
You mentioned a few of the smaller drawbacks as you were leading in. Were there some larger gotchas with migrating into the cloud? As a small web development company that's used to maintaining their own servers and then trying to take that leap,
Yep.
were there some huge mistakes or missteps that you would warn against?
I came into the company, it was a couple of years after it was first formed, but I've come in at a point when our business really started to take off. And some of the decisions, like let's say architectural decisions that were made back when the company first started, aren't so optimal for now. So we've got a number of engineers. We even have one engineer here, Tim Hilliard, who's around the place. Him and his team are working on basically trying to evolve that and develop. As far as you're asking for individual or for stories of problems we've run into, that's possibly one better suited for Tim to ask. He's just a bit more knowledgeable about how our platform runs. Yes. So I'm sorry I can't answer that right away, but yeah, we can talk after. Cool. Well, if that's it, I thank you all for listening and your questions. And if you do need to ask anything else, I'll be hanging around for the whole day. And if I can't answer a question, I should be able to put you in touch with someone who can. So, ladies and gentlemen, thank you.